The goal is to let the child discover on their own that the algorithm learned in lessons 1 and 2 applies perfectly to a larger grid. Even if the size changes, the principle remains the same. There are 2 core experiences. First, letting the child discover independently that the sum of a line changes in a 4x4 grid. Second, having them actively find and apply the sum of the rest excluding one box algorithm in a larger problem. This is the problem we are going to solve this time. Compare it with the problem we solved last time.
It got bigger.
Can you be more specific?
The left one is 3 rows and 3 columns, and the right one is 4 rows and 4 columns.
What changes when it becomes 4 rows and 4 columns?
The numbers going into a line are 1, 2, 3, and 4. Now 4 goes in 2.
Look closely at the shape and position of the blocks and the sum clues. Find a box with only one possible number.
1 and 2 go into 2, 2 and 2, 3.
You are looking at the block with the sum clue first again. We don't know if it's 1 and 2 or 2 and 1. If you only look at the block with the sum clue, you can't be sure. You have to look at the other boxes connected to it to narrow down the numbers. The child can easily think that only the block showing the sum is a clue. The key question in this section is which line does that block have a relationship with? Let the child articulate that the clue is not the block itself, but the relationship between the block and the line.
I will look at the other boxes in the same line as the block with the sum clue.
Good. Then it becomes clear which block is the clue. Which block do you think will narrow down the possible numbers to just 1?
The block with a sum of 3 needs both 2, 1 and 2, 4 added to it to make a line. It's better to look at the block with a sum of 7 instead.
Why is that?
If you add just 1, 4 to the block with a sum of 7, it makes a line.
Is it important to make a line?
Of course. Because we know the sum of a line. The sum of a line is 6, right?
The sum of 3 boxes in row 1 is 7, but the sum of a line is 6? Something's not right, is it?
The sum of a line being 6 was in the 3x3 grid. This is a 4x4 grid, so it must have changed.
Why do you think it has changed?
Because the numbers going into a line have changed. 1, 2, 3, and 4 go into this one.
I see. We need to figure out the sum of a line again.
It's 1 plus 2 plus 3 plus 4, so it's 10.
Good job! Now that we know the sum of a line is 10, try to narrow down the possible numbers.
1, 4 is 3, because the sum of a line is 10, and since the sum of 3 of them is 7, 10 minus 7 is 3.
Well done! Which box from the last problem is just like 1, 4 in this problem?
It's just like 3, 3.
What do they have in common?
That we know the sum of the remaining boxes in a line, except for that one box.
The child connected the two problems and stated the commonality. This is relational thinking. This is the moment they physically feel that even if the size is different, if the structural relationship is the same method works. Now find another place with only one possible number.
I can't really see it. They all have two possible numbers.
In the last problem, not just 3, 3, but 1, 2 also had only one possible number.
Right? It looked like one line plus one more box added to it.
The grid has gotten bigger, but the same kind of clue might be hiding in this problem too.
I will look for a block shape where one box sticks out from a line. I found it.
So did you find the box that works just like 1, 2?
There is one. It's 4, 3.
Can the possible number for 4, 3 also be narrowed down to just 1?
Of course. The sum of column 4 plus 4, 3 is 12. If you subtract the single line sum of column 4 from here, you can figure out 4, 3.
Tell me your answer and add a because.
4, 3 is 2. Because if you add 4, 3 and column 4, it's 12. And since the sum of column 4 is 10, 12 minus 10 is 2.
Let's talk about what 1, 2 in the left problem and 4, 3 in the right problem have in common one more time.
Just like we know the sum of 1, 2 plus column 1, we know the sum of 4, 3 plus column 4.
So the way to figure out that box is the same. How do we figure it out?
We figure it out by subtracting the sum of a line from the sum of the blocks.
The child found and applied the two-line sum method learned in 3x3 to the 4x4 on their own. This is the transplanting of the algorithm. The child has directly experienced that if the structure is the same method works, even if the size is different. Please fully acknowledge this. Use the numbers you figured out first for 1, 4 and 4, 3 to narrow down the possible numbers for the other boxes.
Now I can figure out the numbers in row 2. 2, 3 is 1, and 2, 2 is 2. Because if I put 2 into 2, 3, it will be a duplicate with the 2 and 4, 3.
Good job! Once you've figured out the box with only one possible number first, the two boxes in row 2 also narrowed down to one possible number. You see why that order is important, right?
Because what we find first becomes the clue for the next box.
Keep going.
2, 4 is 4. It's 3 or 4. But if it's 3, it's a duplicate with 1, 4. 2, 1 is 3. The only number left in row 2 is 3. If this happens, I can also figure out 4, 1.
Now, try filling in the remaining boxes. Tell me your answer and add a because. While solving the 4x4 grid today, what was different from our last lesson?
The sum of a line was different. It's not 6, it's 10.
But the same method worked. Why do you think so?
Only the size is different, but using the sum of the blocks and the sum of a line is the same.
If a 5x5 grid comes up, what would you check first?
I would add 1 to 5 and figure out the sum of a line first.